Hello and welcome everyone to the Lab 5, Computer Lab 5. In this lab we want to see that how we can do basic statistical analysis with RStudio. So if you log into our D2L account, so there is a folder here, Computer Lab 5. So we want to first download that file. So you click on here, so you will see that there is a one PDF file here. You can look at that. It's a PDF of the file R code, and here are the source files of the lab. So I just want to download these files one by one and create a directory on your desktop. For example, I create a directory here, and the name of the directory I say lab 5. Now I want to download all these files, specifically R Markdown and the data set, and put them into this file. Download them one by one. Always. So we drag them into this folder. So we don't need this file anymore, so you can close it. So we have lab 5, all the data set that we want to have, and we want to work with this file and create the data set. So what I recommend you, just because it's a RMD, so R Markdown, so I encourage you to open it with RStudio. And by opening this one, so RStudio automatically set, look at, if you click on file, you'll see that all the data sets are available here, because this folder, the lab 5 on our desktop, is our current directory. So everything is fine. So we can step by step we can walk through the commands. First of all, you can run it. We can run the command, and then it gives you it creates your PDF file, all of them. But we want to walk through the command one by one to discuss them. The first topic is about sampling. So we learned in the course that how to take a simple random sample, but believe me, we don't need any table of random digits or other applications. We can take a simple random sample by RStudio very easily. Consider that the first command, reverse. So if you run this command, so you can click here, run selected line. So you'll see that the reverse, it gives us or even you can type question mark reverse. So as you remember, if you open this one, it helps of R, and it gives the reverse command is the data set built in RStudio, and it gives us the 141 major reverse, of course the length of the reverse. So, or maybe I can type length, command length reverse. So we have 141 observations in this data set. But my goal is that we want to take a simple random sample from this data set. For example, I want to take a simple random sample of size 20 of this data set. You don't need anymore to label all the observations from the first one to the last one, and then take labels and then select them. By command sample, you can take a simple random sample of the data set reverse of size 20. So if we run this command, run it, so you can here run selected line, or if you are working with the keyboard, Mac keyboard, command return or command shift, run it. So now you see that we took a simple random sample of size 20 from this data set. We don't need to select the random digit labeling, and directly we can calculate very easily, take a simple random sample. Or sometimes you don't need even to sometimes type the option. Just if you type a reverse 20, RStudio recognizes that you want to take a simple random sample of size 20. But I encourage you to provide the label, the options. So for example, sample, you determine that X, it means that my data set is reverse, and I want to have a size of 20. And the next thing is that if you, the default option for the sample is that it takes a sample without replacement, the same sampling that we learned in class. In other words, if we selected one observation, we do not return it to the population, and we do not give it another chance to be in our sample. But sometimes we want to take a sample with replacement. In other words, we take a sample, and if we have observation selected, we record it and then we return it to the population. So if we want to do it with replacement, so it's called replace equals to true. So if you run this command, this line, so it creates a data set with replacement. So very good. So you'll see that here 620 is selected, the observation, 620 is selected, and then we return it to the population, and then we take another sample and that's selected. So that's why we'll see that it is with replacement, this selection. The next command is that, so how can we take a sample from the data set? So do you remember we have a data set in our directory, which is called the tree.txt file, tree.txt, and we want to, this is a data set. It has a data set of 32 observations and 3 variables, volume, height, and years. And we want to take read this data. So how can it? Because the txt file, so we use the command read.table, and then file the name exact, because the file, the data set is in our directory. We don't need to provide a path to that. We just type the name and the extension of the data set. Because the type of the file is a txt, so sep equals to quotation / t, and then header equals to true. So if we run this one, so you see that we run the data set. The data set is 31 observation with 3 variables. And so sometimes if I want to show entire data set, it may not be feasible. So it's better to use the command head. So command head shows the first 6 lines of the first 6 rows of the data set. So if you run this data set, so you will see that here we have the first 6 rows of the data set. Of course, we have the 3 variable gears, we have height, and we have the volume of those 6 trees. I think this is the data set of the 31 black cherry trees. Or sometimes I can use the command dim to determine the dimension of the data set. So if we call it dim tree data, the name of the data set, we recall it. So the data set has 31 rows and has 3 variables. So what the goal here, do you remember we want to take a simple random sample from this data set? So what we can do, we can use the command against sample, but this time we want to first determine which rows, because each row corresponds to one tree. So which rows we should select. So that's why here our X this time is the number of the labeled from the first row to row 31, because we have 31 rows in the 31 observations, 1 to 31. And now we say that sample 12 labels from labels 1 to 31, and these labels will be the row of the rows of the data set, and then save them in the argument index. So if we run this line, so if I show you the index, so the index now, these are the 12 labels selected randomly. Now we need to select those rows corresponding to these labels. So if you remember, I just provided another example. If you remember, for indexing matrix, so if we have data set tree house, and the data set, and then we want to find the data set in one observation, for example, the observation in the row 24 and the column 2. So it gives us, for example, I want to see that what is observation in the row 3, column 1. So here I call row 3, column 1. So I should get 8.8. And that's why you see that it's 8.8. Now we use this trick for index because we have the indexes. Hope that bad command. I think that's true, but I encourage you always to define the new argument in the left side and the left side. So here, so now I determine that give me those rows that from this data set treehouse, the rows are exactly the same as the labels we generated in the index. So give me those rows, and then I leave the second the second part, which is for the columns, blank. That's why I want to have access to all the columns. So if save it into 312 observation, 312, 3 is 12. So if I run 312, you see that now, do you remember the index we selected? So the first observation selected the 3 in the row 7, row 19, row 29, row 12, row 4. Now the same, now this is exactly 312. The argument is 12 observation selected by simple random sample from the data set 3. So you will see that the 7, now I have access to all the variables for that particular 3 in the line 7, because I left this part empty. It means that I'm interested to all the columns. That was about the sampling. So here I stop here for the first part, and then the next part I'll have to stop it, and then we continue this lab for the line graph and bar chart and the other part. Thank you.